Today we are going to discuss about refraction of light through prism. This topic we have seen in class 10 also, so just it is a type of revision. So here we are considering a prism whose cross section is represented by this triangle ABC. AB and AC we call refracting surface. On AB, the ray is incident like this. Suppose we are saying this is P, this is Q. So PQ is the incident ray. QR is here refracted ray. And this RS is emergent ray. This incident ray makes an angle I with this normal. So this we call angle of incidence. Now this refracted ray makes two angles, one with this refracting surface and one with this refracting surface. So we are considering angle of refraction R1, and this will be R2. So angle made by refracted ray with refracting surface with normal. Now this is emergent ray. So angle made by emergent ray with normal. This we call angle of emergence. Now if this surface is not present, the ray might have gone like this. Now due to refraction at this surface, the ray was originally going this direction, but it has gone this one. So this is the deviation, angle of deviation produced by first refracting surface. And here the ray was going this way, but due to the refraction at this surface, it is coming this way. So this one will be delta 2. That is angle of deviation produced by second refracting surface. Now this delta 2, this is also delta 2, vertically opposite angle. So this is delta 2. Now due to this prism, the originally ray was going in this way and finally it has emerged out in this way. So this angle we call deviation produced by prism. So delta is the deviation produced by prism. Now this angle equal to this and this, exterior angle equal to sum of co-interior angles. So this delta will be equal to delta 1 plus delta 2. Now this delta 1 we can write I minus R1, and delta 2 we can write E minus R2. So it is I plus E minus R1 plus R2. So this is equation 1. Now we are considering this quadrilateral AQ. Here we are giving name M. AQMR. Sum of the four angles will be 360 degree. So this A we are saying this is called refracting angle of prism or sometimes angle of prism. So A angle of prism or refracting angle of prism. If it is equilateral prism or regular prism, the value of A will be 60 degree. For equilateral or regular prism. So if A is 60, naturally B and C, this we call the base angle. These two also will be 60 degree. All three angle will be same. So for equilateral or regular prism, all three angle will be 60 degree. In other cases, if it is isosceles prism, then whatever angle A will be, now these two will be 180 minus A. So this one will become 90 minus A by 2. Similarly, this also 90 minus A by 2. So this type of prism we are isosceles prism we are considering. Equilateral may be, then all three angle will be 60 degree. Now in quadrilateral, AQMR. So this is angle A plus angle AQM plus angle QMR plus angle MRA. This is 360 degree. Now these two angle AQM, this QM is perpendicular, drawn at this point, this surface at point of incidence Q. Similarly, this one is normal at surface AC at point of emergence R. So angle AQM, this is also 90 degree, and this MRA, this is also 90 degree. So these two are 90 degree. Naturally 90 plus 90, 180 will go that side. So what we'll get? Angle A plus QMR will be 180. Well, 360 minus 180, so it will be 180 only. So this QMR we got 180 minus A. Now in triangle QMR, angle R1 plus angle R2 plus this QMR, which we have got 180 plus A, 180 minus A. This is 180. So we got this R1 plus R2 will be angle A. Now from first and second what we are getting? So from first and second we got this delta will be I plus E minus A, or sometime we learned A plus delta is I plus E. Now according to principle of reversibility, if the ray is reversed, here when angle of incidence is I, the ray is suffering deviation delta. Now if angle of incidence is E, that is ray is reversed, it will follow the same path. Naturally this will be the deviation. Ray is going out this way and emerging out this way. So this will be the deviation, and naturally this will be again delta. So whether angle of incidence is I or E, deviation will be same. So we say for a particular pair of angle of incidence, deviation is equal. So for a particular pair, delta is same. So for this particular pair, one of the among this pair, one will be angle of incidence, then other will be angle of emergence. Now if we plot I delta graph, delta we are taking on y-axis, I we are taking on x-axis. Sometimes we call delta versus I graph. or generally it is written I delta graph. We are not giving the versus sign. Versus sign means y versus x always. So then it will be delta versus I graph. So delta we are taking on y axis, I we are taking on x axis, because I is known from before. We can set the prism or we can change the angle of incidence. So when we are changing the angle of incidence for different values, we are getting different deviation. It is observed the deviation first decreases, it becomes minimum for a particular angle of incidence, and then again increases. So this graph will not start from 0, because when angle of incidence will become 0 degree here, the ray may not emerge out or may emerge out also. If the ray is incident like this, it may not emerge out. Some cases it will emerge out also. That we'll see later. What are the conditions under which it will emerge out? So from so here we are saying for this angle of incidence I1 and for this angle of incidence I2, deviation is same. So this is the deviation. That means whether angle of incidence is I1 or angle of incidence is I2, we are getting same deviation. So this is the particular pair. That is when angle of incidence will become I1, angle of emergence will become I2. And when angle of incidence is I2, angle of emergence will become I1. So when I is I1, E will be I2. And when I is I2, E will be I1. And in both the cases, delta is same, that is delta. Now, from here, if you consider this part, again I1 and I2 are very close. Here, further closer. Now, here is this one, this condition, what is that? Here I1 and I2 both will become equal. And this particular deviation we call minimum deviation. Sometimes this graph is asked. So this one will be minimum deviation will be on the deviation axis. We have to mark this. So delta m is here for this particular condition. So when I1 and I2 that is when I is equal to E, deviation is minimum, and let that deviation be delta m. Now when I1 is equal to I2, naturally R1 will be equal to R2. Since this refractive index of material of prism, suppose we are taking this is the refractive index of material of prism is mu2, it is placed in homogeneous medium of refractive index mu1. So refractive index of prism with respect to surrounding, that is mu2 over mu1, can be sin I by sin R1, or it can be sin E over sin R2. So this refractive index, so mu2 over mu1 or mu2 is sin I over sin R1, or it can be sin E over sin R2. Now since this I is equal to E for minimum deviation, therefore this R1 will be also equal to R2. Now we have seen R1 plus R2 is A. So R1 and R2 equal, that means both will become A over 2. So this will be equal to A by 2. Now here I and E both are equal. So delta, that is delta M, will become I plus I minus A. So from second this we are getting this one. And from third what we are getting? This A plus delta m will be I plus I, since I is equal to E for minimum deviation. That means this I will be A plus delta m over 2. So this is the minimum deviation condition, and angle of incidence for minimum deviation. This is number 4, this is number 5. Now 4 and 5 we are substituting this value in. So refractive index of material of prism with respect to its surrounding that is μ(2)1 is given by, so we can substitute sin I will be what? Sin A plus delta m over 2 by sin R1. In place of R1 we are writing, that is R1 and R2 both are same, so A by 2, so it is sin A over 2. So if you are asked derive this relation, you have to start from this place and till here you have to derive. So sometimes this derivation is asked in ISC exam. So this is the derivation of this relation. Now some other facts which we have to know. So what are the other conditions? Or first we'll see for thin prism. So if prism is thin, is less than or equal to 10 degree. If angle of prism is less than 10 degree, then we call it thin prism. And for that what we have to do, this sin A plus dm by 2 is approximately sin A plus delta over, here deviation will be almost same. Minimum deviation or deviation for any angle will be almost same, and that is always equal to, we take A plus delta over 2. Here delta or delta m will not be different because deviation will change very minutely. So we say sin A plus delta m by 2 will become A plus delta by 2, because sin theta is theta when theta is very small, and sin A by 2, which is sin R1 or R2, this one will be approximately A by 2. Therefore this μ(2)1, that is refractive index of material with respect to its surrounding, if it is air, then μ1 will become 1. If it is different, when it is immersed in water, suppose μ1 will become refractive index of water. So this one will be A plus delta over 2 by A by 2. That means refractive index of second medium or material of prism with respect to A will be equal to A plus delta, or this delta is A μ(2)1 minus 1. This is the deviation for thin prism. As these two here, when sin is approximately sin theta is approximately theta when theta we are taking in radian, but as here both are in radian, it is in ratio form. So if you are placing both in degree, then also result will be same. So no problem, we have not to change in degree radian. If A is given in degree, delta is given in degree, we can use this relation to solve the numerical. This relation is valid only when the prism is very thin, that is approximately 10 degree. Like sometime we consider the lens as thin prism. So this is for thin prism. Now other facts we will discuss. So now what are the conditions to be satisfied during minimum deviation? Two conditions already discussed. Angle of incidence will become angle of emergence, and that value we have already derived. It will become a plus delta m by 2. Angle of refraction will become equal to R1 will become equal to R2, that is angle of refraction at first surface will be equal to angle of refraction at second surface, and that will be equal to half of the angle of prism. The third one is, if this I is equal to E, naturally what will be? This glance angle of incidence, which we call X, or suppose this is equal to glance angle of emergence, because these two is 90 degree. This is perpendicular, this is, so this E plus Y is 90, I plus X is 90. So naturally glance angle of incidence will be equal to glance angle of emergence. So glance angle of incidence now third one is glance angle of incidence will be equal to glance angle of emergence. So this angle, suppose this is X and this is Y, these two are equal. Now the fourth condition is, as delta 1 is I minus R1, delta 2 is E minus R2, I and E both are equal, I minus R1, E minus R2, I and E are equal, R1 and R2 are equal. Naturally the difference of these two will be also same. So this delta 1 will also be equal to delta 2. But delta 1 plus delta 2 is total deviation, and total deviation is here delta m. So this is delta m by 2. That's why sometimes we call condition of minimum deviation as symmetric deviation also. So this, due to this fact only, delta 1 will be equal to delta 2. So it is symmetric deviation case. Now this refracted ray will be parallel to the prism. This will be in case of equilateral prism or isosceles prism. Minimum deviation will be only in these two cases only. So from here we are getting, this is already 90 minus A by 2. Now this one R1 is A by 2. So this angle will become 90 minus A by 2. So these two angles equal. So these are corresponding angle. So this will be parallel to this base. So refracted ray is parallel to base of the prism. So in question paper, if any one of these condition is given, out of these 5, if any condition is given, automatically the remaining 4 will be satisfied. So you can use the fact while solving the problem. If any one condition is given, these all 5 conditions are equally valid. Now we are discussing two special cases for normal incidence and grazing emergence. That is, ray is incident normally. So here it is making angle of 90 degree, that is angle of incidence is 0 degree. This R1 will also be 0 degree. This is R2, and here E will be also 90 degree. So when angle of refraction here, angle of emergence 90 degree, so naturally this R2 will be how much? So this R2 will be equal to critical angle. Now this A is R1 plus R2. So 0 plus IC, that is equal to IC. So this A will be equal to critical angle, then this condition will be satisfied. So if A is less than IC, then whatever the angle of incidence will be, it will never suffer total internal reflection. It will always emerge out. The ray will always emerge out. It will not suffer total internal reflection. Now, second case is for grazing emergence and grazing incidence and grazing emergence. That is, ray is incident parallel to the surface and it is emerging out also parallel to the surface. So here angle of incidence I is 90 degree, E is also 90 degree. This is R1, this is R2. So here R1 and R2 both will become So this R1 and R2 both will be critical angle. Naturally, this angle of prism will be twice of critical angle. Now, if angle of prism become more than twice of critical angle, whatever the angle of incidence may be between 0 and 90, whatever the angle of incidence may be, it will always suffer total internal reflection. That is, ray will never emerge out. So that condition we have. So the condition is, if angle of prism is more than twice of the critical angle, the ray will suffer total internal reflection. That is, here angle of incidence will become more than critical angle. Naturally, it will suffer total internal reflection. It will never emerge out. And if it is less than IC, it will always emerge out. So between IC and 2IC, if the angle of prism is there, then in some cases it will emerge out, and some cases it will total internal reflection will suffer. That will depend on the angle of incidence also. Okay, so in prism only you have to do this much. Thank you. Now next class we will see other topic.